Okay, so here we are, starting the fifth application in this course, which I personally think it is also the most interesting of all. In the next lectures, you are going to see how to build a Python program that connects to a single router in the network and uses SNMP to extract the values of some objects, then displays the entire OSPF network. After the program makes the necessary extractions, it asks the user how it should provide the information received from the network. The user has to choose from a range of three options. The gathered data will be either displayed in the console, or exported to an external file using a predefined format, or, finally, and this is the most interesting part, assembled into a nice graphical map of routers running OSPF in the network. I have my GNS3 network already open. This time the only connection is between my virtual machine and router R1, as you can see, because a single connection is all we need in this case. Let's check that OSPF is running in the network. For this, I'm going to ask R3, which is connected to all the other routers, for its OSPF neighbor table. Show IP OSPF neighbor. So in this output, we see the OSPF router ID of each neighbor and the IP address of that neighbor's directly connected interface. Nice. Also, keep in mind that the virtual machine should have R1's management IP address configured as default gateway, and it does. This is it right here, or up here. And R1 should advertise the management subnet to the rest of the OSPF network to be able to query each router. And again, it does. Let's see R1. And notice here the command that advertises this subnet to the entire network. Now let me open a Linux terminal and run the application. Okay, first let's go to the folder in which the application file is stored. So, home, Debian, working directory. Okay, the password is Debian. First, notice a message being printed out. It tells us that we should make sure we connect to a router in the network that is currently configured with OSPF and that all routers should have the same SNMP community string configured. Our routers meet these conditions, so let's move on to the next step. We should enter the IP address of router R1, the so-called root device in our case. So, 192.168.2.101. Next, we are asked for the community string we configured on each router. In this case, we have the default read-only string, public. Notice that, as usual, first we check if the IP address is valid and also reachable. If the program passes this step successfully, then it is time to pull out the values of the OSPF SNMP objects. After the extraction has been completed, we are asked to choose an option. Let's try each one. If we choose the first option, then the program shows the information it extracted from each router. So we have the hostname, its own OSPF router ID, the router IDs of its neighbors, and the IP address of the directly connected interface of each neighbor. This is where the Colorama module helps us to display a nice output using a different color for the most relevant information. Next, let's choose the second option and see the results. We are notified that a file has been generated in the current directory, so let's see that file. Cat ospf devices.txt. This is similar to a CSV file, comma separated value, only that we use a semicolon to delimit the fields we need to separate. The first row describes the meaning of each field in the rows that follow. So this is the first row right here. First we have the hostname, then the OSPF router ID, and then information about the neighbors in a list format. This file can be further imported to Microsoft Excel for a better view. Now let's return to our application and see the result of choosing the final option. So, 3. Let's maximize this. Okay, nice. The program generates a map of all the routers that are running OSPF in the network. So, comparing to the network in GNS3, we can see router R3 in the middle of the OSPF network, and the other routers as its neighbors. Instead of the host names, we have the router ID written on each network element in the diagram. Furthermore, we have the IP addresses of the interfaces printed on each side of each link between the routers. So, Notice these IP addresses right here. From within this window, we can save this OSPF topology using the Save button right here into a JPEG or PNG format. Okay, cool, really cool. Finally, if you close this window, you are redirected to the main menu, and choosing E will get you out of the application. Now let's make a plan and see the code for this awesome program.